Okay, I want to go over this before start 4.2. So we did this. F of x is equal to, I want everybody to watch because the ones who's turning in their work, great. Those are good. But I want to also I want to make sure that you understand. You're not just doing this, but you have to understand what you are doing. Okay, we're writing a program so you can have a better understanding about the concept of mathematics. Okay, especially Newton's method. So understand this, because I'm so glad Avian asked me yesterday. She's asking me, what is x1? What is x2? What is all that? So let's understand what that means. So let's just working with the same function we've been working with, x squared minus 5 times x and plus 4. We got that, right? And then we're gonna say f prime of x is equal to 2 times x minus 5. We got that. And then we decide to use x0 to be 3.5. Right? That's the one that, like, now look at this one. Okay. So remember that, and then x1, we decide to use x. So we're finding x1 using Newton's method. Newton's method says your next x, the better approximation of x. Okay, that is how do you find that is this formula, x of 0 minus f of x of 0 divided by f prime of x0. So we get that number, new number. So let's look at what that means. Okay, that means, let me see whether I can, there you go. So that means, all right, my graph looks like this. I know that number is 4, but that's not my concern. Right now, I'm gonna say, let's say, if I have really, really hard equation, some equation that I cannot solve algebraically. Of course, I can solve this one algebraically. This is equal to x minus 1, x minus 4, then x is equal to 1, and x equal to 4. I know that, okay? I'm using the equation that I know how to solve, so I can verify that my approximation, numerical approximation, is working correctly. I cannot check whether this is correct or not unless I already know the answer. So I need to work with the ones I know how to do. And when I know that, then I can say, okay, I can apply this into the equation. That's very, very hard. All right. So right now I'm saying, okay, say I pretend this is just something that I don't know. Okay. So I'm gonna say, okay. I said, okay, I'm gonna try 3.5 to be my number, starting number. So starting number, x0 is 3.5. Is everybody with me? Now I'm gonna say, I'm gonna use this Newton's method right here. So I'm gonna say, okay, that means I draw a line over here, and that's my tangent. I'm gonna draw a line. Okay, so I found a new x. This is x1, which is equal to that number, 4.125. Does it make sense to you, class? I cannot hear you. Or show me your face and tell me whether you understand, especially Davian. Are you following me?
Yes, ma'am. So
now,
one is,
now let's, I'm going to say my tolerance to be equal to 0.0001. Okay, so I'm going to say, okay, let's see, it's ABS, absolute value of a first number that I found, minus the very first number that I'm starting with, is that less than equal to tolerance? It says false. That means my tolerance is smaller than the difference between those two numbers. So let's see what's the difference between those two numbers if you want to see it. The difference is 0.625. Of course, 0.625 is bigger than 0.001. Okay, so you're gonna say, okay, I need to keep doing my iteration. So you're gonna come back here. So now we gotta find my x2 then. So I'm gonna do, okay, let's find my new iteration. Okay, so I'm gonna find a new iteration. All right, so I found my new iteration. So that new iteration gives me now, so I'm gonna say, okay. Okay, so I'm gonna see my new iteration. So new iteration says, okay, my new iteration says, okay, so I got this number right here. It's 4.25. So I'm gonna do my Newton's method again. So I come over here and I'm gonna draw myself a tangent again. Excuse me, I'm not drawing my tangent well. So let me draw myself a tangent. Oops. I need to draw myself a graph first. Okay, so I'm gonna draw a tangent. So I'm gonna draw a line that goes through this. Okay, and so I found a new number right here. This new number right here is x2, which is equal to that number, 4.0048. Are you following me? Okay. So you find a new number, each using a Newton's method, you find a new number. And you're checking that new number with old number, like you did x1 minus x0, you get the number equal to 0.625, it's greater than a tolerance. So you still have to do your work. You can stop the work when the difference is what, less than equal to tolerance. Then you can stop. Okay, are you following me now? Do you understand better now?
Pairs.
Yes.
So when you say x1, is that like an actual number or this?
Yes, it's actual number that you found it. You calculate it. This is how you calculate it.
I'm saying, like, is it like actually, is we saying 1 minus 0 or x1 is 4.125?
Right, that is the number. See right here, that number right here is x1, which is 4.125. X naught is a real number. X1 is a real number. X2 is a real number. That's all you can compute. You're really computing because number minus number is a number. Yes, it's a real number. I call it variable because I need to calculate, I need to use that variable to figure out what I need to do. So like X2 is another number, X3 is another number. Yes, it's another number that you calculate it using a Newton's method. Does it make sense to you now? Davian, are you following me?
I am, but when you do X3 and X4, how we know what Julia think X3 and X4 is?
Because I'm gonna tell them like this one is X2. I calculated, that is X2. So how would you figure out X3? You do exactly the same way. So X3 would be what then? X2 minus f of X1 minus, f of X2 minus f prime of X2. So there's another number, 4.00 something, that's X3. And X2 is 4.0048. Are you following me? I want to know X5, X4, what do I do? Changing everything to the one bigger number now. So I got my new number. Okay, so now you got X4 is equal to 4.00000000, very small number. So you know for sure now X4 minus X3 should be less than tolerance, which is true. That's 0.000000. This is the same as 0.0000123456. which is a very small number, which is what? Definitely less than equal to 0.001, the tolerance. So I can stop. So ABS, so you do and I can do tolerance, it's gonna say true. Does it make sense to you now? So the avian, I'm not really understanding about what is your concern about X1, X2, X3, and X4? Why you think Julia does not know that number? I cannot hear you.
Hello?
I cannot hear you, the avian. Okay, I will wait for you until you can make your microphone situated. Anybody else has a questions? Kevian, are you following me? Why you got an error on yours? Chevian, you sent me a work yesterday and you got an error on yours. Do you understand why you got an error? All right, can you guys hear me okay? Yes?
Static.
What is it? Is it static? I'm at school, so I thought school has a better internet service than my home. My voice cannot, you don't hear me well? Yes or no? Type it, put it in my chat box. Can you hear me well? Then say yes. You don't, then say no. Put in a chat so I can see whether you can hear me or not. Can you hear me well? Okay, so Jalen, you can hear me fine, and Benjamin, yes. India, yes. Jalen, I want you to look at what I wrote. Make sure your syntax is correct. A lot of time you get it wrong because your syntax is wrong, which means you put space, that we cannot put space, or you put a capital letters when you cannot put capitals, because it's a computer programming language is a case sensitive. What you type is exactly has to match. Otherwise, it does not recognize. It does pattern match. So if you put the capital P instead of lower p, or capital X instead of lower x, it's not going to work. If you're using underscore zero, it needs to be underscore zero, not minus zero. Okay, so look into that. All right, glad everybody can hear me. Okay, then that's good. So Jalen, what do you mean by that? It's the sign. So if you want to share your screen and show me, that'll be fine. All right, you guys. Jalen, are you going to show me something now? Or can I move on to the next lesson? All right, so let me go over one more time. You need to send me your Julia code that you do one line by line coding like what I just did. I need that. You need to send it to me today. I know you guys sent me yesterday was incorrect. You need to fix that and send it to me today. I will still give you 100%. And next thing, you have next homework, which is watching video, the Julia Academy video that I uploaded. I gave you a link on your Blackboard and also GroupMe. You need to watch those videos. So just short videos, like 5 to 10 minutes videos. They got quite a few of them. You have no problem watching them in a few days. If you want to watch everything in one day, that's also fine. Some people, one of my students watch everything in one day, in a few hours and done with it. So watch that so you have a basic concepts of a Julia coding. So watch that before you do your programming for your semester projects. So your Julia coding, you need to watch those. Julia Academy videos, you need to watch those. When you finish watch, they will give you a certificate. They give you on your, so you have to create your account. And you watch all that and it's saved in your account. When you finish your watching all the videos, they gave you a certificate says, congratulations, you finished this. You need to, and then you're going to put your name there so they know to put congratulations, Jalen, congratulations, India. So, okay, then I know it's that you watch those and you finished, and that'll be your proof. So you need to send me that. Okay, you need to email me that. Put the screenshot and email me that. Okay, so you have, that will be your homework due this Sunday. By this Sunday, I need to see that certificate. By next Wednesday, I need you to send me your Julia project, okay, semester project, which means you cannot just do one line by line like this, but you need to write a code. Okay, like say function. So you need to write a function. Function, Newton's method. And that takes like that. And then I'm going to start with the finding a x1 is x0 minus f of x0 minus divided by at prime of x 0. And then if you want to use a while loop, that's fine. You can do while and then do whatever you want to do. Okay, so I'm just coding. Or you can do if and then do your coding. And then you're going to end. I want you to return the value. And then you end. So that's basically what you have to do. Okay, so this is what I need to see. Entire function, you need to write a function that does automatically. Right now, you're doing individually. So you need to watch that Julia Academy coding video so you understand how to do if statements, you know how to do while statements, you know how to do print statements and things like that. All right. So you got to watch that video so you can have a basic concept of a Julia programming, which is the easiest programming language ever that made. Easier than Python, easier than MATLAB, easier than Mathematica, easier than C and C++. Almost every language you can think of, Julia is the easiest one to do. And it's very powerful because it's a higher language. All right, so that's enough for the Julia. So I put the, whenever you see a sharp sign, that means it's a comment. So Julia does not evaluate whenever you see a sharp sign, because the sharp sign means a comment. It knows not to evaluate. All right, so that's it for that. We're gonna moving on to our lesson. All right, so we're gonna continuation from yesterday. So yesterday we learned that a derivative is you going down and find an instantaneous rate. Okay, you're finding a rate of something, rate of speed, like a rate of whatever, rate of a car or rate of something. So derivative is the same thing as finding a rate of something. Okay, for in case thinking about it, the speed, right? How fast you're going, that's a rate. That's a derivative. That's instantaneous of derivative. And then but integration is opposite. So integration means I am finding an area under the curve. That's what integration is. Okay, is everybody following me? So derivative, you can think of finding a rate. Finding a rate of something, rate of car, speed of a car, or rate of a ball through like some kind of rate, okay? Speed or velocity is a derivative, okay? You can think of velocity as a derivative, okay? Now, integration is, you can think of as an area under the curve. How much area does it cover under the curve? That is what integration is. Okay, so I'm trying to give you the physical sense of what integration is, physical sense of what derivative is. So physical sense of a derivative is a velocity. And physical sense of integration or antiderivative is area under the curve. So that's what we're going to learn today. So that's why it's called area. So use sigma notation to write an evaluation. Understand the concept of area, approximate the area of a plane region, find the area of a plane region using a limit. So sigma notation. So sigma notation means addition. That's what that means. Whenever you see a sigma, Whenever you see a sigma like that, okay, this is called sigma. This sigma means it's addition. It's a Greek letter. It's upper Greek letter sigma, which is write it down like that. That means it's addition, a sum of n terms of A1, A2, A3, A4, all that. You can write it down as like this. So I don't want to write down, I don't like to write down all this. Say 1,000. There's a lot of numbers I need to write down. I don't like to write down like that. So I can rewrite this one as using a sigma and say sigma starts with a 1 to 1,000. And I can say I. Okay? That means I am replacing I with the number starting with a 1. So very first number, I'm going to put 1. What's after 1? That's a 2. What's after 2? That's a 3. What's after that? 4. I'm keep going, and then when do I stop? It says, okay, this is 100. It's 100, and I will stop at where? 100. That's what that means by sigma. Okay? Sigma means, it's a Greek letter, okay? The uppercase Greek letter sigma means it's addition. Addition of each term. Okay, it has each term. So example, if I give you, say, sigma I equal to 1 to 100 I square. What does that mean? That means first number square, first term plus second term square plus 3 square, 4 square, and I'm going to keep going. When do I stop? India, when do I stop?
100 squared.
Why do I stop at 100?
Um,
the upper limit says
yeah.
100. I stop at 100 and square. That's what it means. All right. So here's an example. In this case, it's I, just I. So you go 1, first term plus, second term plus, 3, 4, 5, 6. It stops at 6 because upper limit is 6. In this case, I start with a 0. So it'll be 0 plus 1, which is same as equal to 1. That's what you have here. Next one, 1 plus 1 gives me 2. That's what you have here. This means what? 3 plus 1, which gives you 4. This means 2 plus 1, which gives you what? 3. I will stop at where? 5, which is 5 plus 1 gives you what? 6. All right, next one. It starts at 3. So you need to watch. So this is your starting number. The bottom number, which is called lower limit, is a starting number. What's this upper number? We'll call it upper limit, which is what? Ending number. You end at that number. That's why you stop at 7 square, and you start at 3 square. Does it make sense to you, class? Anybody have a question so far? Is everybody good? Okay, this is the most popular summation formula. So I want you to kind of know this. Yes, you can use your notebook when you take your exam and when you do your homework. So, for example, if you have a constant and you have a upper limit is n, that means constant times the upper limit. Next one, if you have this, they gave you formula, which means if I have I start at 1 and ends at 100, of I know what the summation equal to. They gave you formula. The formula says what? N times n plus 1 over 2, which means 100 plus 100 plus 1 over 2, which gives me 100 plus 101 divided by 2, which is 50 times 101, which gives me one number then. 50, 50, right? Right? That's what I have. So I don't have to add individual one to figure out what that would be. I can just use this formula to figure out what the summation is. When I add all the numbers, I know what that equal to. Like 1 plus, 2 plus, 3 plus, 4 plus, 5 plus, all the way to 100. I know what that equal to. That's equal to 1050 according to this. All right. And there's another formula. This is a very popular formula too, and here's another popular formula. So when you do your homework problem, you can use this to do your work instead of trying to figure out everything by hand, by adding the numbers. Also, your calculator has that too. Okay, so now area. So if I give you this, the triangle, how do you find your area? The area of a triangle is what? 1/2 times what? Base times height. The 1/2 came from a rectangle. When you do a base times height, when you get a base times height, give you a rectangle. Area of a rectangle. All right. But the rectangle contains two triangles. You see there's one triangle right here. In the other place, this will make the other triangle when you add it together. That's why you have to add, when you multiply by half of that, give you triangle. The triangle is, two triangle makes one rectangle, in other words. Okay, that's why you got the half came from. Okay, you have a parallelogram, hexagons, and polygons, all those things, you can find your area. Like you can find the area of your circle using a pi r square. All right, so now we're going to find the area of a curve. Okay, we're gonna find the area of a curve using a calculus. But before I do my integrations, let's thinking as a summation first. Because remember, area integration is area under the curve. But I am not going to use integration yet, but I'm going to use a summation. So you can understand, physically understand what that means. For example, if I want to find the area under the curve of the first picture, okay, if I draw rectangle like this, 1, 2, 3, 4, 5, okay, there's 5 rectangles. So how would you find the first area of a rectangle? You're gonna do what? The base times what? Height. So this case, the first rectangle is equal to base times height. My base happened to be 2/5. My height would be what? Someplace right here. That would be f of 2/5. This is my function right here. Okay, my height is right here. My height is x is 2/5. The f is what? The y value is what? F of what? 2/5. What's my point right here? How can you find the point right there? That point right here would be, look at this, that's my x value. So it'd be 4.4/5, and then what? F of 4/5. Okay, next one. How do you find this point? That point would be, you will look at your x, which is 6/5, 6/5, and f of 6/5. All right, let's find the next one. How do you find the point right there? That point is what? Looking at this, 8/5, and then what? F of 8/5. All right, one more. How do you find the point right there? The point would be what then? 10/5 and F of what? 10/5. That's how you find yours. So in other words, I can find area under the curve or this rectangle. Rectangle 1, rectangle 2, rectangle 3, rectangle 4, rectangle 5. When I add them together, I get an area under the curve. They are actually a little bit smaller than the real curve, but I can find approximation of the curve. So area under the curve, in this case, I'm using rectangle 1 plus rectangle 2 plus rectangle 3 plus all the way to rectangle 4 plus and rectangle 5. All right. So let me draw a picture. Okay, so all right, let's draw the picture again so we can kind of better understand with a clear picture. Okay, so this is what we have. So what was the picture that we have? 2, 4, 6, 8. Is that what we have? What's the picture that we have? So I can use same thing. 2, 4, 6, 8, 10. Okay, and then the equation is that. Okay, this is what my graph looks like. And the thing that I was looking at was what? Let me see what the graph looks like. Start all the way to 2. Okay, this is what we have. And they draw a rectangles. Okay, this is what we have. So you can see it. So when you find the area of those rectangles, you can kind of approximate the area under the curve. The curve is a black line, okay? But as you can see, when you do inscribe rectangles, you're going to have a less than the real area. Okay, so with this area, which is lower, I'm finding a lower limit of area approximation. Okay, so this one, if I want to find the area of this, the first one. Okay, so I'm going to say rectangle. First one. Area of a rectangle, first one. What do? You're going to the what? Base times height. Base is the base is 2/5 because my x is 2/5. So this right here is a 2/5. Okay, 2/5. By the way, this case, all my base, okay, my base, all this thing right here is a 2/5, okay? My base is a 2/5. That's a common base. Because they're incremented by 2/5. Okay, but height is different. So h is height. Okay, so very first on my height would be f of 2/5, which is 2/5 times f would be what? So it'd be negative 2/5 square plus 5, which gives me 2/5 times 4/5 plus 5, which gives me, you put it in your calculator, that will give you what, times 5. 5 is the same as 25 over 5, right? So the 29 over 5. So you multiply this, you get a 25 over what? 18, 58. 58 over 25, that's my height. I mean, the 29 over 52, 29 over 5 is your height, and your area is 58 over 25. So this area right here, that area is 58 over 25. Okay, let's find the area of second one, blue rectangle. What is my area of this blue rectangle? You find what? Again, base times height. Base is what? We already know it's 2/5, it's fixed. Height in this time is, I'm gonna plug it in, 4/5 as my x. So I have a 2/5 times negative 4/5 square plus 5, which gives me 2/5 times 16 over 25 plus 5. That's the same as 2/5, 16 over 25 plus 25 over 5. Oh, did I make a mistake here? So this one should be 25, isn't it? So the 75 over. Okay, this number is wrong, so I need to put that in my calculator. This number is definitely wrong. Okay, so this number is wrong. So put in your calculator for me, or I can put in my calculator. So it'd be negative 2 over 5 is the same as 425 plus 5. So 2/5, 425 plus 5 is the same as 25. If I want to do 5 of them, 5 times 25 is what? 75? No, 25 times 5 is what? 5 times 5 to 125. So 125 over 25. So my answer is 2/5 times 129 over 25. So whatever that number is, your answer. 75 over 129 times 2 is your area for this rectangle, the red rectangle. But anyway, I think I need to go over this one again with you tomorrow because we only got 4 minutes left. But the concept that you have to understand is the integration is area under the curve. And right now, I'm not using an integration to figure out the area under the curve, but I'm gonna use a summation of each individual rectangle to figure out my area under the curve. So because you need to understand, physically understand what that means by area under the curve. So you actually draw a small rectangle for each small rectangles under the curve, and then you physically find area of rectangles, each one of them, and then you combine together, they become a entire area of under the curve. Since this rectangle is under the curve, under this curve, okay, and then you can see there's some parts, like this part, like this part is missing, that part is missing, and that part is missing, and that part is missing. So the area that we're gonna find is smaller than real area under the curve, but it's okay, because we can also find the more than area under the curve, and we can combine together and divide it by 2, which will be very similar. Okay, so I will continue this lesson tomorrow. Yes, you can do some of your homework problem because you have learned something. And then yes, we'll go over some of the homework problem tomorrow from 4.2. All right, so if you are here, say I am here, so I know I can do your attendance. And I need your homework, turn it into me today. The Julia coding, the Julia single line coding, I need those today. And you need to watch your videos and give me the certificates by this Sunday. All right, class? Any questions from today's lesson? Is everybody good? All right, if you don't have any questions, I will see you tomorrow. I will see you Tuesday, and I will continue 4.2. All right, talk to you guys later. Have a good weekend.